So one of the things in AP Pre-Calculus that you need to know are just different ways of representing polynomial and rational functions. Different ways that you could see them. Maybe be able to look at a graph and pick out the correct multiple choice answer of the correct function notation, or be given a function and have to sketch it out, kind of like this most previous test, or most recent test. So let's look at this first example. Here is a rational function, h of x. Write an equation in factored form and find any values of x where the function has a whole or a vertical asymptote. So this is just straight up review, nothing new right now at all. I want you to take this h of x equals, draw a fraction bar, and then you can just factor the top and the bottom. The top is a difference of squares, but just be really careful. It's not x plus 4, x minus 4. What is it? If you factor this. There you go. Don't forget to take the square root. X plus 2, x minus 2. And then the bottom, you're just needing to ask yourself, what times what equals 10? That adds to give us 7. And that's going to be 2 and 5. Once you factor it, and that's a key step, because now you can see anything that's going to cancel more than likely is going to end up being where a whole is located. And here you can see that the x plus 2's cancel. There is a whole at x equals negative 2. Anything left over in the denominator that did not cancel out is going to be where you have a vertical asymptote. So here we're going to have a vertical asymptote at x equals negative 5. We're going to throw on this component, and I think most of you will find this is pretty easy once you've done it a couple of times. If you're asked about the domain, that just means what x values are included in this graph or in this function. And the answer there is basically any number except for these two. You have to exclude these x values because the graph at these x values does not exist. So the way you're going to write that is in interval notation, you're going to say anything from negative infinity up to negative 5, but not including negative 5. We would not want to plug negative 5 in. Unioned with, I'm basically just skipping right over the negative 5 there. I'm going to pick right back up at negative 5, and I'm going to go up to negative 2. I'm going to union that with, well, I'm just skipping right over the negative 2, and then anything else is fine. So if you want to make a note to yourself, you're just going to exclude wholes and vertical asymptotes in your domain. Any other x value, you could plug it in and it would not cause a 0 in the denominator. Zeros on the top are fine. We just don't want a 0 in the denominator. We weren't able to see that until we factored it, so that's why factoring always seems to be the first thing that we do. All right, we're just going to practice that again. Here's another function, k of x. Take a second and make sure that you can factor k of x. Let's see. There's a GCF on the bottom. There's an x that you can factor out of all of those terms. And if you ever needed to show a little bit of extra work out to the side, that's totally fine. Don't feel like you have to do all of it in your head. Something times something that's negative 20 that adds to give me positive. I'm going to skip part B for just a second. I'm going to go to the stuff that's more familiar. Does this graph have a hole? Where? Good. At x equals 4. Now this specifically says find any values of x where there is a hole, so 4. We're on part C. We skipped part B. We'll come back to it. D says find vertical asymptotes. Okay, so anything that we did not cancel out on the bottom becomes a vertical asymptote. Now I know that the -5 is pretty obvious, but there's another vertical asymptote. Where is it? It's at 0. Very good. If you take this factor and you set it equal to 0, you will see that there's another vertical asymptote at 0. Wonderful. Okay. Let's go ahead and do horizontal asymptote. That's where you have to go back to that Betsy, Bo2, Bobo. You have to look at the degrees at the top and the bottom. And I like to just go back to the unfactored one so I can clearly see the degree is bigger on the bottom. Bigger on bottom means 0. Now listen really closely. On the test, some of you knew that and you did this. You put something like 0. And I gave you partial credit because I know you understand. But it's not just 0. You have to tell me a little bit more. If we're talking about a horizontal asymptote, you need to write the equation of a horizontal line. So what is missing there? The y equals, very good. If you put 0, I just took 1 point off. If you put x equals 0, I put a -2 because I don't even think an AP grader would give you any credit for that. It's y equals on a horizontal asymptote. So any extra stuff you want to be writing down, feel free. Okay, now let's go back up here to the zeros. I didn't skip it because it was difficult. I skipped it because a lot of you, this is just kind of the missing piece to the puzzle for a lot of you. The 0 is where a graph will come in contact with the x-axis. It's either going to bounce or it's going to cross. And where you could find that is anything that didn't cancel out on the top. That will help you a lot when you draw the picture. So here, this graph is going to come in contact with the x-axis at -3. But listen, is it going to bounce or is it going to cross at -3? And how in the world are you going to know that? Does anybody want to take a guess? Is it going to cross at -3 or is it going to bounce and go the other direction? Because this class, that's one thing that I noticed as a whole, we missed on the test were the multiplicities. And what I'm talking about here is multiplicities. It is going to cross. Those of you that knew that, how did you know that? The multiplicity of that is odd. It's a 1. Odd numbers, 1, 3, 5, 7, 9. If a factor has an odd multiplicity, it's going to cross the x-axis at that location. If it has an even multiplicity, it's going to bounce and go the other direction. So again, that'll help me when I draw it. And then the domain, let's see if we kind of understood from earlier. The domain's going to include everything except for holes and vertical asymptotes. So I'm going to leave all 3 of these numbers out of the domain. So this one's kind of a pill. There are a lot of parts to this one. -infinity up to, just start with your smallest one, -5. And then -5 up to the next smallest one, 0. And then 0 up to the next one, 4. And then 4 up to infinity. Okay, part of the drawing is going to be easy. Part of the drawing on this particular problem is going to be really tedious, so hang in there with me. Let's do the stuff that we know. You guys were excellent at, and a lot of you got credit for drawing the vertical asymptote. So here we've got one at -5. Just a couple of you got horizontal versus vertical confused, so you drew them flip-flopped. And then we have another vertical asymptote at 0. And we have a horizontal at y equals 0. We have a 0. We know the graph crosses the x-axis at -3. The one on the test was not this difficult because the one on the test didn't have this middle piece that we're going to have to figure out today. I'll tell you this, a lot of you, if you can find the actual location of the hole, that will also help you. So let's pause and make sure we remember how to do that. Go back up here to where you wrote x equals 4, and I want us to add to that. 4 what? Like, what's the ordered pair where I'm going to find a hole? Do you remember how to find that? There's a lot of stuff that we've learned that we're having to put together here. You're going to plug it in, but you're going to plug it in once we've canceled out. Okay, so bear with me here. On the top, that's 4 plus 3, which is 7. And on the bottom, we're going to have, if I plug in a 4 right there, that's 4 times 4 plus 5 is 9. And you might be thinking, well, that does me no good. I don't know where 7/36 is. Well, it's a really teeny tiny number, and it's positive. And that's really all you have to get out of that. Check this out. If I go to my picture, I can know that there's a hole at 4, and then really almost just above 0. It's positive, so I knew it was above, and draw a hole right there. That tells me that there's part of the graph hanging out up here in this little section. Here's what we're going to have to do to figure out this middle piece, because I need to know, is it like kind of almost like a parabola in the middle? Is it doing the weird like cubic shape? And there's all kinds of things that could be taking place. So here's what we're going to do, and it's this easy. You are going to retake the free response. Listen to me. You can plug in any x value you want and see what y value you get out of that. That's going to be a point on the graph. So let's plug in -4, and then the y value will tell me, do I put the point up here? Do I put the point down here? So let's plug in -4. I'm going to go right back up here, and I'm kind of going to be making a sign chart. I want to figure out what's going on to the left of that vertical asymptote. I want to figure out what's going on between that vertical asymptote and the 0. And I want to know what's going on between that 0 and the other vertical asymptote. So it's essentially just a sign chart. If we can see if y is positive or negative, then we're going to know how to draw this thing. Again, this is way harder than the one that was on the test. All right, so if I plug in -5, I'm going to plug it in after the canceling has already taken place. So -5 plus 3 is going to give me a negative on top. On the bottom, I'm going to have a -5, which is a negative, times, or excuse me, I'm plugging in -6, I guess, sorry. A -6 plus 5, which is another negative. So here's what I've just learned. To the left of -5, the y values are negative. That means this has to be happening. The y values have to be negative. They have to be below the x-axis. All right, let's figure out what's going on in the middle. Let's pick a number between -3 and -5. Let's make it -4 to keep things easy. Between -5 and -3, the y values are positive. So they're up here. Now we're just going to plug in a number between that 0 and that asymptote. Any number you choose. I'm probably just going to choose 1. 1 plus 3. 1. 1 plus 5. Everything's nice. And oops, I should be getting a negative. I'm sorry, I should plug in -1. My bad. -1. So -1 plus 3. -1. -1. Okay. Finally, the y values are going to be negative between the x values of -3 and 0. So now I know it's doing this. Now, one thing I want you to add in there that the notes don't say to do, but this was the last question on the test, and it was write the limit statements for end behavior, and we really struggled with that. So let me just kind of re-explain how in the world you do this, okay? For end behavior, we're talking about what's going on way over here to the left, way over here to the right on the ends. That means you're always, always, always going to have what symbols right here for end behavior? Negative infinity and positive infinity for left end behavior and right end behavior. As x is getting infinitely smaller, as x is getting infinitely bigger. If the directions say end behavior, your limit statements will always start like this. And then we're going to write k of x. We need to figure out what are the y values approaching as this graph goes off to the left forever. Well, check this out. As this graph goes off to the left forever, y is getting really close to what? But it's never going to touch it. What did somebody say? 0. It's the horizontal asymptote. And to the right, it's going to be doing the same thing. It's getting really close to that value of 0, but it's never going to touch it. So it's approaching 0. So last period they said, okay, is that always going to be true? Is a rational graph for end behavior always going to be approaching the horizontal asymptote? And the answer is yes. So if you kind of like to memorize things, then there you go. Okay, that one was really tedious. Let's turn the page. We're going to go completely backwards now. Here is the picture of the function, and we're supposed to come up with the equation of it. And that seems kind of daunting, but if you break it down into parts that you know, it's really not that bad. Some of you are going to like this. So let's just start with something everyone's good at, vertical asymptotes, and I see that there's one at 2. So when I write this, when I draw my fraction bar, what factor needs to show up and where? Can you tell me that? Like, what does that mean? When I get down here and I say, all right, f of x equals, and I'm ready to write it, what does this tell me? Just think completely backwards. How have we been coming up with a vertical asymptote of 2? X minus 2 on the bottom. Cool. X minus 2 needs to be in denominator. Okay, and then there's a hole at x equals 1, 2, 3, 4. So what does that mean? What factor needs to show up where? Good, both top and bottom, because it needs to cancel, because things that cancel give us holes. Where does this graph come in contact with the x-axis? At 3. Does it cross at 3 or bounce at 3? It crosses. So we just need to make sure our x minus 3 has, that it's on top, because zeros are located on top, and that it has an odd multiplicity. And if I get to choose, what's the smallest odd number? 1. So let's keep it simple. And then lastly, let's talk about the horizontal asymptote. It's at y equals -1. But this kind of falls outside of the pattern of what we've been doing. It's not like we're going to have y plus 1 somewhere. What does that tell you? That's way back when we learned the Betsy, Bobo, Bo2. And if you end up with y equals a number, JT, excellent. So that's your Betsy. For those of you that don't know, bottom equals top, you look at your leading coefficient. So that just tells me this. When I get this thing written out, I need to make sure that the leading coefficients equal -1. The degree needs to be the same on top as it is at the bottom. All of that will help you piece it together, and that's all we really need to write this. So here we go. F of x equals, and draw your fraction bar. We said that there's a vertical asymptote of 2. There's a hole at 4. 0 of 3. And there's only one other little thing. Is the degree right now the same on the top as it is the bottom? Yep. Is the multiplicity of this odd? Okay, good. So there's only one thing I need to stick on here to make sure that the horizontal asymptote is -1. Just a negative on the front. Because, and I'll show you here in pencil, that would create that -1/1 leading coefficient situation. So just stick a negative on there, and that's it. That's all there is to it. We don't need to think beyond that. Well, let's try again on example 5. Vertical asymptotes. There's 2 this time. Good. 0 and 3. So that means on the bottom I need to have x minus 3. And how am I going to deal with that? What kind of factor would give you 0? Just an x. Very good. You've done all of this forwards. Now we're just going backwards. Kind of makes your brain hurt a little bit. There's a hole at 2. X equals 2. So I need to make sure that's a factor that shows up in both the numerator and the denominator. Where's the horizontal asymptote? There actually is. It's just not a clear dotted line. The graphing program didn't put it as a dotted line. Yeah, it's right across here. Good. So y equals 0. It's essentially the x-axis. Is that Bobo, Bo2, or Betsy? Bobo, which again, for those of you that always think I'm a crazy person when I say that, that just means bigger on bottom means y equals 0. So now I know my degree needs to be bigger on the bottom. And then there's one more little thing. Where does this graph come in contact with the x-axis? Where's the 0 of the function? 1? So x minus 1 needs to show up on the top. If you put all that together, there's not anything extra to think about. And that is it. So g of x, write an equation in factored form for g of x. Vertical asymptotes, there are 2 of them. A hole. A 0. The way that I've written it here, what's the degree of the top? 2. What's the degree of the bottom? 3. Is it bigger on bottom? Then we're done. That's it. That's all. So I hope now that kind of going forwards and backwards, graph to equation, equation to graph, that free response will become a lot easier for you. So you can gain those extra points, those of you that want to come in and do that. Okay, now we're going to switch gears, and this is going to seem super random, but it does tie into things that we've learned and what we're learning. This concept of a slant asymptote. So look at this picture. This is a rational graph. It does not have a horizontal asymptote. So in Algebra 2, how you learned it was, okay, if it's bigger on the top, it's just undefined. That may have been where you stopped in Algebra 2. It can mean 2 things. It could mean there's a slant asymptote, or it can mean there's neither a horizontal or a slant. So the rule was, when we learned this before in this class, if the degree is exactly 1 bigger on top, it's got a slant asymptote. If the degree is any bigger than that on top, then we're just going to put neither. It doesn't have a horizontal, it doesn't have a slant. There are graphs that have neither of those. Really weird. But what we need to talk about is, in AP Pre-Cal, you might be asked, what is the equation of that line? What's the equation of the slant asymptote? And you may have, some of you may have actually learned this in Algebra 2. We just use long division. I know that doesn't sound fun. Some of you are going to like it though. We use long division to figure that out. Think y equals mx plus b. If I'm asked to find the equation of a line, I need the y equals mx plus b. Okay? So here's how we're going to do this. I want you to jump down to that bottom box on the left. Let's talk about how long division used to work back in the day when we were in elementary school. We didn't have calculators, and we had to do like 676 divided by 21. The first thing you do is you write your 676 inside and the 21 on the outside, what you're dividing by. And then you just start a digit at a time. 21 doesn't go into 6, so scoot over. 21 goes into 67 3 times. So skip a space and write the 3 over the 7. Those tiny little details are going to be really helpful to you today. And then technically what you're doing is you're needing to then write, well, what is 3 times 21? You're distributing back out, multiplying out. And that's 63. What do you do with that 63? Subtract. And you end up with 4. Now what do you do? Bring down the next digit. So all of these things are still going to be true today with dividing polynomials. And then you just start the process over again. How many times does 21 go into 46? Well, it goes in there 2 times. 2 times 21 is 42. We're going to subtract that. And we have 4. Now, there's nothing more to bring down. What do you call that 4 that's left over? You call it a remainder, and back in the day, we just wrote a big R and we said the remainder's 4. So right underneath there, the quotient is 32. That's the part that's before the remainder, and the remainder's 4. But your answer would actually be this, 32 and 4 21sts. Now, where did I come up with that? What 2 parts did I make this fraction from? What 2 parts made this fraction? I guess I should ask. The remainder goes on top, good, and then the dividend, or what we're dividing by, at 21, goes on the bottom. Really good. And that's all the same rules apply when we start dividing polynomials. So we're now ready to do this. We have this problem that says take this quadratic and divide by this linear equation or expression. So let's get it all set up. You might want to write kind of small. 6x squared plus 7x plus 6. By the way, you have to have a placeholder. So like if this just said 6x squared plus 6, I would have to fill in the gap and put plus 0x. There's one homework problem, and I kind of wish there was more. There's only one homework problem where you have to make sure you put in a 0 term. So just make sure you kind of remember those details of if it starts with the squared, you have to have a linear, you have to have a constant. Okay, and then we're going to divide by 2x plus 1. All you need to do to get started is look at your first term divided by your first term. So I always go off to the side and I write, okay, 6x squared divided by 2x. First divided by first. That gives me 3x. I'm going to go back over here and I'm going to line it up with the x column, 3x. Lining things up is going to be helpful to you today, and I'll tell you why in a little bit. Technically, what we then do is we distribute that back out because we have to subtract the product. So 3x times 2x is 6x squared, and 3x times 1 is positive 3x. But what did you say we did over here with the 63? We have to subtract. So everybody listen really closely. The number one mistake is people just put a subtract symbol in front. But we have to really subtract all of it. So my first period students were telling me they just prefer to go ahead and switch the signs as they write it. So they would have written it as minus 6x squared minus 3x. So if you want to switch the signs as you write them, go for it. But those first terms should cancel out. If they don't, you did something wrong. And then that's technically 7x minus 3x, which is 4x. Then you bring down the plus 6. You start over. First term divided by first term. 4x divided by 2x. Well, that's just 2. Positive 2. So I'll go back up here and I write plus 2. And then I distribute that back out. If you want to write them, the signs changed as you go, here's how you can do it. 2 times 2x is 4x, so minus 4x. 2 times 1 is 2, so minus 2. Those cancel. They always should. You end up with 4. You actually would not go up there and write a big R with a 4. Let's jump down here. The quotient is 3x plus 2. The remainder is 4. But I bet you can help me with this. The answer is going to be 3x plus 2, and I'm going to add the remainder. And over here we said the remainder goes on top of the fraction. What we're dividing by goes on the bottom. So it's going to be plus 4 over, what were we dividing by? Very good. Remainders are messy and ugly, and here's the great news. For slant asymptotes, you get to completely ignore the remainder. Don't even worry about it. Turn the page and I'll show you what I mean. Here is h of x. Use long division. Find the slant asymptote. So you get to practice the long division stuff again. 6x squared plus x plus 5 divided by 2x plus 1. I wish this was a little bit different than that first one. It's very similar. All right, so we're going to do first, bless you, divided by first. Off to the side. First term divided by first term. That's just 3x. I'm going to line it up with the x's. Distribute back out and change the sides. It's going to be negative 6x squared minus 3x. 1 take away 3 is negative 2x. Bring down the plus 5. First divided by first. That's just going to give me negative 1. So go up here and don't write plus 1, write minus 1. You can stop there. Don't worry about going any further. The lining things up is going to help you because it tells you when you're done, because you guys, if you're trying to find y equals mx plus b, there it is. The remainder doesn't really have any meaning to us right now until you get to calculus. Here's the slant asymptote. Can you tell me what is the slope of the slant asymptote? What's the slope? 3. What's the y-intercept? Negative 1. Excellent. Okay, cool. Let's move on. Example 7 says, the task is a little bit different here. It just says, find the equations for any asymptotes. And it lays it out for you. Vertical, horizontal, slant. Okay, here we go. Factored form. I don't really feel like I have enough room right there, so I'm going to bring it out here. Factor the top and the bottom. Once you've got it factored, you want to move ahead of me, go right ahead. Vertical asymptotes. Are there any, and if so, where are they? Negative 6 is not going to give a vertical asymptote. I was actually going to ask that in a minute. Why not? Yeah, he's going to cancel out. So there is a vertical asymptote, but just one at -1. Yeah. No graph is going to have a horizontal and a slant. It's going to be one or the other or neither. So let's look at this. I go back up here. The degree on top is 3. The degree on bottom is 2. It's 1 bigger on top. There is no horizontal asymptote. We have to do long division to come up with the equation of the slant. X cubed plus 4x squared minus 12x. Technically, it's not really going to make a difference in this problem, but this is what I was talking about. If in descending order, if you're missing a term, you need to put like a plus 0x squared if you're missing the squared term or something. Now, that really isn't going to change this process in this problem. And you might think, oh my gosh, this one's going to take forever. It actually doesn't, because look what happens. This is kind of cool. If you take x cubed and you divide by x squared, you already get your linear term. So you get to jump right over here. And guys, you always should. If we're writing the equation of a line, that slant asymptote is a line, it's never going to have an x squared in it. It's not a parabola. And then we're going to distribute that back out and change the signs as we go. So that would be negative x cubed, negative 7x squared, negative 6x. And then start all the way over. First divided by first. And stop when you get to the end of your terms. After your constant, the remainder doesn't matter. Now be careful, if you were to come back over here and write this, you get some partial credit because you did all of this work beautifully. But really, what's missing if we're writing the equation of a line here? You need to tell me that it's y equals mx plus b. Y equals x minus 3. Let's look at a different style question. This one's multiple choice. And it says, here is this function d of x. Which of the following is true? Well, before I even look at answer choices, and I messed up on this one last period, but before I look at answer choices, I notice that the bottom is factorable, so I'm going to go ahead and factor that. That's going to be minus 1, minus 1. Because if you've noticed, we kind of always just start with our factored form. So x minus 1 on the bottom. Well, what I did last period is I just thought, oh, there's a hole, and I crossed them out, and then I went to my answer choices, and I said, well, D can't be right because it says no holes. But wait a minute. Is there really a hole at 1? Isn't the rule that if something cancels out, it's a hole? But there's not a hole at 1. Can you tell me why? There's still that factor, even though those canceled, there's still an x minus 1 in the denominator. What that means is there's a vertical asymptote at 1. Remember, you can't have both a hole and a vertical asymptote in the same location. So there is a vertical asymptote. So, answer choice B is out because it says that there are 2 vertical asymptotes. Answer choice A is out because it says that there's a hole and there's not. And answer choice C is out because it says that there's a hole and there's not. Now, if you're taking the AP exam, you're pretty sure you're about to circle D. Just double check. How do you know that this has a slant asymptote? Prove it to yourself. How can you prove it? Right, and so yes, if you were to have to find that leading term on top, it would be 2x times x, which is 2x cubed, and the degree on the bottom is 2. It's one bigger on top than it is on the bottom, so it has a slant asymptote. So there are lots of different ways to tackle that one. You could have started with that. Number 9 is very challenging. I want you to just challenge yourself and see how much of this you understand, but it is very challenging, okay? All we have is limit statements, and we're supposed to draw a picture of the graph. So let's start over here. There's a reason why I'm having you start here. When you have a limit statement that says, as x is approaching this number -1 from the left and the right, y is going down forever. As x is approaching -1 from the left and the right, y is going down forever. That's the type of limit statement that's telling you about what? Is it telling you about a hole, a vertical asymptote, horizontal asymptote? What is it telling you? Vertical asymptote. There's a vertical asymptote at -1. Because of the way that's written, it says, as we come to that vertical asymptote from the left-hand side, y is getting smaller. I just need to make sure when I draw this that when I'm hugged up close to the vertical asymptote on the left, I drew it in pencil, it's kind of light, but that y is going to -infinity. And this last limit statement says, as x approaches -1 from the right, y is also going towards -infinity. Now here's where I might lose some of you, and it's okay. I won't put anything like this on a test, but don't just tune me out. This says, as x is approaching positive and negative infinity. So this is telling you about end behavior. It's telling you as x gets bigger and bigger and bigger, aka right end behavior, on the right, y is going down forever. So I'm just going to go ahead and draw that in my picture. And as x is getting smaller and smaller and smaller, as x is approaching -infinity, aka to the left, y is getting bigger. So I'm going to draw that in my picture. What this tells me, kind of behind the scenes, is there is no horizontal asymptote, because if it was a horizontal asymptote, x would be approaching a number. If there's no horizontal asymptote, that means that there's a slant, and it doesn't matter where you draw it, just draw a slant asymptote in there. How did I know the slope was decreasing? Why didn't I draw it the other way? And that the clue to me was the end behavior. And now I can kind of just almost connect the arrows. So over here, this part will satisfy the end behavior. Y is going up forever on the left, and it satisfies the vertical asymptote behavior. Here, what you're going to have to do, because you can't really connect those arrows, is you're going to have to just draw it in this region here. And that will satisfy the end behavior and the vertical asymptote behavior. So the slant asymptote thing just is really challenging to wrap your mind around just based on limits. But you won't see anything like that difficult on the test.